Alrighty, I am on the marie.js.org webpage. So this is an online simulator. It's similar, but probably not 100% the same as the simulator that you can download and that some schools will ask you to use. And so you be aware that there's just a couple things different, but not too many. All right, so let me get my thing lined up. So I'm going to go through the tour, so the basic tour. And so I'm just clicking on help, and I'm going to hit rerun tour. And here it goes. So this tour introduces the features and how to use Marie.js. Next. And then they have added a spot where you can go to Google Services, so you can import and export from Google Drive if you want. This is the coding area, and this is where you can type your code. You can debug it by opening the watch list and clicking to the right of the line to add breakpoints. The green line shows current execution, gray line shows fetch line. All right, so when you start doing the fetch, decode, and execute, this will help you out here. All right, so next is it shows you your registers. And so you have the accumulator, the instruction register, the memory address register, the memory buffer register, the program counter, and these are your ins and outs for your I/O devices, I believe. I think that's right. Okay, the values and outputs. This is the output mode. You can pick whether you want it in hex, decimal, Unicode, or binary. This shows you the output in the register log, output values, and how the data is being transferred. And then notice up here you got output log, RTL log, and watch list. So let me click on all of those. RTL log, watch list. Input list is where you can choose. All right, so let's go back to output log just in case. Next, the status bar down below. This is the status bar. Shows you your error messages or your status to help you with your debugging. You select your output type. I think we already talked about that, but you can change the output type here to hexadecimal, base 8, decimal, base 10, ASCII, base 16. It is defaulted to hex. All right, the way down here, this is the control bar used for controlling the execution and the assembly of the code. So you do have to hit assemble first before anything will work, but then you have a step, a micro step, a step back, run, and a restart. You also have a delay, so if you actually hit run, you can delay the speed. All right. Assembling the code, this button builds the code. So again, you have to hit this. Once you have your code up here in the assembly code area, you can hit assemble, and then that's when you can start running your code. This steps one line through the code. So when you hit step, it goes one line at a time. So if you have 5 input, it's going to ask you for an input, and then once you give it, it's going to go to store X, which is line 6. Micro steps through the code by each individual command here. So we'll have to do that to see how small that is. Stepping backwards through the code. If you can read this, it says this is an awesome debugging feature where you can step back through each individual line to see where you've gone wrong. And run the code. What else? This button can also pause the current execution during code execution. So if you hit it again when it's running, it'll pause it. And restart. Have you tried turning it on and off again? This does exactly that, but also preserves the memory contents. And delay slider, we talked about this earlier. You can actually slow it down if you need. All right, this is the data path. This is actually pretty cool. I think when you do your homework assignments and you play with it a little bit, you'll kind of like this a little bit more than you think. And so what it says is data path helps you visualize how the simulator works by illustrating how micro instructions are performed on the CPU. And the status bar up top, same as the one shown in the home screen, shows you the current status, also shows error messages. And that's it. Hope you enjoyed your tour. Thank you. Bye-bye.